Hey guys, welcome to a special episode of Build Onchain. Today we've got two members from our own team. We got Kiryl and Sammy. They're going to talk about a thing that we just released called Permit3, which is an extension of Uniswap's Permit2, kind of takes it cross-chain. So Kiryl, why don't you start and tell us a little bit about how you got here, the work you did before.
Hey everyone, so my name is Kiryl Yermakou. I have over a decade, so like 17 years of software engineer at this point, spent most of the time doing front-end, back-end, and for the past 7 years, got into Solidity and blockchain and cryptography and things like that. So I built a couple protocols before, mainly the biggest one was Axelar, general message passing, cross-chain contract calls, and governance and a bunch of other components for the interoperability. Worked on a couple other things and then ended up at Eco, to solve this not a simple problem of making stablecoin or in general like on-chain user experience seamless regardless of amount of tokens, chains, and other things that raise level of complexity.
Nice. And Sammy, you want to go as well?
Sure. Hey everyone. My name is Sammy Liu. I've been working in the crypto space since 2017. So worked at banks, crypto exchanges, and then Axelar as well. So I was one of the earliest engineers who joined Axelar. So like basically like design and did the protocol from end to end, everything. And then I just joined Eco like May this year, started looking at this intent-based solutions to try to get stablecoins cross-chain.
Awesome. All right, guys, why don't we talk a little bit about Permit3? What's the idea? What is Permit3?
All right, so Permit3, the idea.
Yeah,
a
just
little
like a
bit
high
of
level.
background. Yeah, so if anybody knows, there is a thing called Permit2 created by Uniswap. And Uniswap created this for purpose of being able to authorize several tokens with one signature. And the whole idea is that we have Permit that built into ERC20 tokens, but not all the tokens supported. There is some fragmentation in that regard. And also like for each of the tokens, you need to have user to create a signature, and that does not scale well. So to improve that a little bit, Uniswap created Permit2 contract that allows users to create several token allowances just with one signature. And yeah, so this was like breakthrough in its own way, and also it allowed Uniswap to support tokens and have gasless transactions for tokens that don't have permit built in them. But it was still limited like in many other regards. So I believe it solved the problem that Uniswap had, where gasless transaction like for Uniswap X and being able just to authorize tokens for swaps with one signature without user submitting any transaction or paying any gas, and that was pretty much it. And after like scrutiny and deeper expansion of that solution, there was a lot of limitations to it. For example, we can have like a batch with many permits in it, but we cannot have token transfers. So to do token transfers, you need to call a separate methods with a array of token transfers. And in our solution, we created this like universal message type where user can increase allowance, decrease allowance, or send tokens directly and have like a mixed batch of such operations. On top of that, Uniswap Permits is a single chain thing. So pretty much like for each chain, user needs to sign a message. And in order to fulfill our mission here at Eco to create seamless cross-chain stablecoin experience, we made Permit3 implementation to be cross-chain. So that means with one signature, user can move or create allowances as many different kinds of token on as many chains as possible with just one signature. And on top of that, Uniswap's Permit2 supports only ERC20 token. And in our Permit3 implementation, we also support NFTs and ERC 1155, which basically allows Permit3 contract to work with any type of asset.
Very, very cool. Okay. Sammy, do you have anything to add to that? Otherwise, we can jump right into the little demo and like walk through.
Sure, yeah. Well, I can quickly talk about my opinion or the way I look at it, but like,
Sure.
well, essentially, like technologies build on top of each other, right? So like back in the days, we started with ERC20s where people started doing approvings and transfer from. That's great, but then it's great in a way that you can create allowances for someone else to move your token. But then the problem being that you would have to still hold Ether or the native coin to pay for the gas there, right? So that's why like permit system was introduced, but then it doesn't work with existing ERC20s. And that's why like Uniswap, they came in and say, hey, we're gonna do this Permit2. So you just set up the allowances to our contract to set things up. And then you can start like signing, stuff off chain, and then just give the signature to the on chain, and then someone else can pay for your gas. And now what we are doing is we're trying to build on top of Permit2, right? So like to solve some of those problems that Permit2 was not able to do, or like they didn't have those kind of problems, or like the time wasn't there. But now we're dealing with like a multi-chain kind of world, and you do want to set up allowances across different chains with one signature, right? And that's where Permit3 comes in. So these things all stack onto each other, and we're trying to make it more and more better in terms of the user experience.
Nice. Yeah. Makes sense to me. All right, do you guys want to walk through the code a little bit? Go.
Yep. So looking at the Permit3 repo, for anyone to remember, it's github/eco/permit3. So here we have an introduction that explains how this thing works. Basically, on the front end, user can create a signature, and signature, let's say we're trying to create allowances for 3 different chains. It's Ethereum, Arbitrum, and Base. So we create batch of allowance increases, decreases, or direct transfers for each of the chains. And then we hash each of them and create a Merkle tree. And then when we submit the signature on each chain, we submit only the relevant part, which is, let's say, if we submit it on Ethereum, we have only Ethereum allowances, and other chains, they're replaced with a Merkle proof. And in order to achieve unprecedented gas efficiency, what we did, we are leaning heavily into unbalanced Merkle trees. That means for the most expensive chain like Ethereum, the proof length is just going to be 1 leaf. Because the tree is unbalanced, and the upper level we just have at the root, we have Ethereum and everything else. And to prove Ethereum, you just basically need to submit only 1 leaf, and that minimizes the amount of data and on-chain processing, proving, and stuff like that. What else? So we basically, we do not expect user to create any Merkle tree or do anything with that. So Permit3 comes with SDK that allows user to basically be abstracted away and also to create a nice experience for any developer. But the idea and our vision is that over time, Permit3 integrated with different protocols and a lot of different apps using it. And in this case, user will already have Permit3 authentication set up. And by that, I mean that in order to use Permit2 or Permit3 contract, ideally, user will give this contract an infinite allowance for the token. So the Permit3 contract cannot do anything with the token itself, but in order to move funds on user behalf, user need to give allowance to Permit3 contract. And our goal is, to spread adoption and have user base that already authenticated Permit3. And that means for any other app building on top of it, they don't need to go through any initial setup, ask user to give initial allowance or submit any transactions. So the future that we see that user just gonna create 1 signature, and in 1 signature can create any amount of on-chain actions, DeFi composability, move funds across chain, or aggregate funds from multiple chains, move it to another chain, and then have some DeFi action happening there. So this is the general vision here. And also, like, in order to improve initial setup, we also created some integrations with smart wallets. So we have two things: is ERC 7702, which basically, let's say if user do not have smart wallet upgrade, but they want to create one-time integration approval for all the tokens for Permit3, they can just upgrade their account to 7702 token approver that allows anybody's on user behalf to create infinite allowance for their ERC20 tokens to Permit3 contract. So just with one opt-in, we allowing to create that experience where a user sign a transaction, upgrading their contract, and after that, they don't even need to worry about creating allowances for their ERC20 tokens to Permit3 contract. That can happen seamlessly in the background, and all user need to do is just authorize token allowances and transfers again. But in the case where a user do have smart account already, we have implemented ERC 7579 smart account module that allows just install that module into many compatible smart wallet solutions, and to achieve the same thing, that after installing the module, user automatically granting permissions for all their ERC20 as well as NFTs and ERC 1155. And in this case, just doing one action allows user to completely integrate all the existing and all the future tokens with Permit3. And with cross-chain nature, unfortunately, we cannot just do like one action and do all the chains at the same time. So setup needs to happen for each chain, but each chain, one signature, one transaction. After that, all the tokens automatically integrated with Permit3. And if we want to look a little bit more into how unbalanced Merkle true is operating, here is a little bit of visual example. So we can say that D7 is going to be the most expensive chain, which is Ethereum, and all the cheaper chains can go into that balanced aspect of the Merkle tree. And like, let's say this is Ethereum, this is like Binance, this is Polygon, and this is bunch of cheap L2s. So what happens is when we submit transaction for Ethereum, we still reuse the same signature for the root. Here we're going to include all the permits, allowances, transfers for Ethereum, and the rest of the chains can be just replaced with one hash, which is H3, that represents the hash of all the other sub-branches and sub-tree. And that allows us to be super efficient and use minimal amount of gas, aggregated across all the chains. And for some cheaper chains where we don't care about Caldera cost, we can just put them into that balance tree. And because by the end of the day, it's just Merkle free. It's a simple thing to create and to integrate. The balancing can happen differently depending on the use case, and it is super flexible this way. And we have extensive documentation. So for anyone who wants to dive deeper into like examples, getting started, things like that, we have pretty extensive documentations here in the docs, in the repo. So please welcome to explore that and see all the guides, all the concepts, and as well as all the like APIs, different error codes, data structures, everything is described here. And just like to look at simple sneak peek, we can take a look what do we have inside of our like per chain batch. We have this data structure, which is universal. So it can describe transfer of the token or creating an allowance. So this first entry, is exactly what it says. So if it's some unique number like 0, that means it's a direct transfer. If it's 1, that means we are creating allowance. If it's 2, we are like decreasing allowance. Or basically, like if we actually increasing allowance instead of like a small number, that will be like an expiration type step. So that means that like any allowances that are created that can expire in the future. This is the address of the token, and this is account that is going to be able to spend the token, and this is amount delta. The reason we call it amount delta because that can mean allowance increase or allowance decrease. And again, because we're using this like universal structure, now we can pack different types of operations into the same batch of operations and sign it all together. And in storage, we are storing allowance this way, where we have an amount and expiration, and also we have timestamp that allow us to synchronize expiration updates. And one of the additional difference that Permit3 has over Permit2 is ability to submit bunch of operations asynchronously, because we're not using any type of sequential nonces. Rather, we're using like asynchronous nonces that just allows to create these permits in a high-paced environment where, like, let's say some high-frequency trading or anything else like that happens, or high flow of transaction, and still being able to resolve everything without any race conditions. And some protection mechanisms that we have account locking. So let's say if there was some allowance granted, and also there is some other permits in flight, and at some point we realized that destination contract got compromised or anything else like that, user can submit an account locking command that's just going to completely lock out this compromised actor from being able to move any funds.
Quick question.
Yeah.
I was muted before I meant to ask this. So the non-sequential nonces, is that just like basically you like a hash of the data in there? Is that like how that works?
Yeah. So basically, when user create a signature, or like when some SDK or software that user operating with creating a signature, part of the signing data is going to be the salt, and salt is pretty much random numbers. So salt basically just like can be random. There is no ordering there, and any salt can be used only once. So in classic permit approach, you have like incremental nonces that mean like you create an allowance, you sign in the nonce one, then if that nonce was not utilized, you need to create another signature for the nonce one and submit that to increment the nonce, and that basically creates this this like locking condition where, like, to invalidate nonce, you need to create like another dummy allowance for yourself. And or like if you need to create 3 nonces at the same time for different protocols, now you need to make sure that they submitted on chain in the right order. And if you're working with some third-party protocols, they're not going to be able to coordinate that. So our solution pretty much eliminates all these kind of problems.
So like rather than it being like a monotonically like increasing nonce, it's just like values that's like this nonce is used, so can't use it again.
Yes,
and just
exactly.
like the space is so big that you're never gonna. Okay, got it. Sweet. And then one more thing. So these structs that you had before, these are not. Maybe this is a stupid question. These are not the things that are stored in this Merkle tree, right? This is like a change to an allowance. This is not the allowance itself.
Yeah. So like this is pretty much what is stored like in contract storage, and this is the struct that is like essentially stored in the Merkle tree, because we have a batch of those. So essentially it's going to be like array of those data points, and then we create array of those per each chain that we assign it for. So we have another data structure that says chain ID these, an array of those things, and then for each chain we're pretty much going to submit a batch of those things, and for every other chain that is not the current target chain, we're just going to replace them with a Merkle proof.
Got it. Cool. Makes sense.
Okay. And also, here is like a little overview that like for Permit2, we only have method which is transfer from, which is designed to move ERC20 tokens. In our case, we have these additional methods that allowing us to move NFTs and ERC1155. So we're pretty much supporting any type of major asset out there. And here is just like a little bit of example, of how we could create allowances for chain. And yeah, so this is like allowances, like different types of operations. One could be like increase allowance. The second operation, we are locking account for some other account, and then we also can just execute direct transfer. And usually permit will be only associated with allowances, but At Eco, we have the most efficient way to create on-chain intents by creating unique vaults representing user action. And we also like able to work with allowances. And in this case, someone can create an allowance and then our vault can consume that allowance and do a transfer form on user behalf. But the most efficient way to do things is just to do a direct transfer into the vault. And that's where this like mode 0 comes into place, that we're creating some unique on-chain action that needs $20. And the most gas efficient way to do it is just to transfer that $20 directly into a deterministic vault address. So that's that. Any questions at that part?
Yeah, maybe this is like a lower level like Merkle tree question. So any change of any kind to these things like results in a regeneration of the tree, right? So then you have to kind of like get the
yeah. So after Merkle tree is created, and it just pretty much, like the way hashing works, if someone will try to temper any kind of data, even like that type of a deep node, it's going to propagate the different chain hash up on the like node chain, and basically changing D2 going to change this hash, then it's going to change this hash, and that's pretty much going to propagate up to the root. So just signing one root allows us to pack any amount of data in there, and all this data is guaranteed to be cryptographically integrated and not being able to tamper with.
And then so like it doesn't matter if I'm making a change to an allowance for an existing chain or like activating a new chain. It's a similar like idea, either I add a leaf or I modify a leaf, but then either way, treat like the Merkle tree has to be regenerated, and then it's the same process.
Exactly,
right?
exactly.
Okay, sweet.
Yes.
Cool.
And what else? And here, just like an example of data structure is how we do cross-chain permits. So in this example, we have, Ethereum, and what is this guy? Optimism, maybe. Basically, this is how data structure looks. As we say, there is an array, a batch of these universal operations, and then a chain ID. And one thing worth mentioning is because we essentially using ERC 712, and we want to use the same signature across all the chains. In our signature scheme, where we have domain separator, the domain separator is set to be universal chain ID, which we chose to be 1. So even if someone like creating allowances or permits for Arbitrum, it's actually Arbitrum. So in this case, the signature that they created in MetaMask, it's still going to pop up and say that we are signing for Ethereum. Because the way ERC 712 domain works, we had to pick one chain ID and use it universally. And Ethereum is a default chain; it's available in every wallet. So that's when we went with chain ID 1 for the domain separator itself. And the actual authentication for which chain we're signing the permits for, it is stored inside of this struct. Here you can see it is chain ID and array of permits for that chain ID. And then we basically hash those things, creating leaves, and then based on leaves, we create the Merkle root, and then the signature basically created for the whole thing, including the Merkle root.
And then you said there's an SDK for this, right? Because this all seems very
SDK,
confusing.
I believe it's not released yet, but we are basically
gotcha.
building the SDK. And the user, like one of the things is, of course, how powerful this technology is, but at the same time, when you make technology advance, there is so many nuances and so many things to do things wrong. So that's why we also at Eco, we're very, focused on developer experience, and any technology that we release, we also create SDKs and different kind of libraries, making sure that integration is as seamless as possible and nobody needs to write some code, and dig into like how that works under the hood, because essentially, it can be just abstracted away under convenience method in the SDK.
Super cool. Yeah, this seems very powerful. The ability to do like cross-chain permits is very, very nice, and like to do all of that with one signature rather than having that like scale to the number of chains and tokens you're using is really cool.
Yeah. And making sure that, like this Permit3 support is not gatekept by our deployment process or anything like that. We're deploying Permit3 using ERC 2470 Singleton Factory, which basically allows anyone to deploy into a new chain and result into the same address. So we brute forced result and created this cool address, for the ECA Permit3 system. And currently we just deployed on a few chains, but what's going to happen is we're basically allowing anyone to deploy onto any new chains and result into the same address. So which is pretty universal and not gatekept. So even we're going to be relying heavily in our user experience on Permit3, but we're really striving for wild adoption for that.
Mm-hmm. I guess, yeah, on the subject of like adoption from people, like how do you imagine this will be used like within the space going forward? It seems like this is really powerful. It seems like people would benefit from this. Like what use cases do you see emerging, I guess?
Yeah. So one thing is, since we've been following, we're building on the shoulders of giants, and we've been following the pattern of Permit2 itself. So for any existing smart contract that is already integrated with Permit2, has an ability to consume Permit2 allowances, we kept method signatures to be the same. So if some contract is able to do transfer from based on Permit2 setup, they're also going to be able to integrate or drop in Permit3 immediately without any need to modify their source code. That is amazing. And so basically, like for single chain applications, there is maybe not direct benefit to just jump into Permit3. Like if some application not running into the problems or limitations of the Permit2 solutions, they maybe can keep using Permit2. But at the same time, as soon as someone is building cross-chain applications and, interoperability is widespreading every day, a lot of major institutions launching their own blockchains, and there is not going to be less blockchains or less stable coins in the future. So that's why we see that adoption of this cross-chain universal solution is inevitable.
Sweet. Yeah. That's what I was. There's a lot of like movement towards more interoperable stuff. There's like all these like groups forming of people who like the people who want to basically make the cross-chain experience easier. This seems like a really like strong move in that in that direction. So excited to see it.
That's right.
Yeah. Sammy,
I think also like with adoption of like 7702, like the account abstraction thing, right? Like this Permit3 thing will take a lot of advantage of that, because with smart accounts being all over the place, like the setup can also be done gaslessly with just a signature, because the message sender is always gonna, like, you just send the signature over to that account, verify that, the message sender being that account, and then you can do the allowances. And also with smart account, you sort of guarantee that like money will always be there when the permits gets executed, et cetera, et cetera. So in this kind of multi-chain world, with 7702, I think there's a lot of potential with use cases when it comes to Permit3.
Mm-hmm.
Absolutely. And I think the important thing to note there is that with 7702, now we truly can have gasless experience.
Exactly.
That means people can just own just USD token, USDC, never own ETH or any other gas token, and just operate gaslessly, creating signatures and doing on-chain actions. And I think that's where adoptions can truly spread.
Yeah, and also the notion of own is kind of changed nowadays, right? Like it used to be that you have to have like a private key where the address is stored with balances inside that ERC20. But now you can just own something that can authorize a smart account to do some token transfers, and those can be pulled together in that actual ERC20. So like, yeah. Like even the setup can be gasless. I think, yeah, the whole thing eventually should be gasless.
Yes, and I think it's already possible. It's already
Yeah.
possible. It's just like matter of user adoption, trusting into smart wallets, and yeah. Still, there is like a lot of push, for example, from MetaMask, but still not many users choosing to upgrade their account into MetaMask smart account and so on.
Yeah, as always, user adoption is a challenge. The gift
Right.
that keeps on giving. Cool. Well, thanks, guys. This was very informative. I guess, like, yeah, if people want to look more into this, oh yeah, we'll put the link in the bio here, in the description, and yeah, thanks for coming on, guys. This has been
Happy building.
Happy building.
Contribution is welcome.
Yes.
Yeah, any feedback, please, the easiest way, just open an issue on the GitHub repo, any future requests, because we're still thinking about a couple ways to improve, and there is a possibility we might deploy a new version of the thing. Mainly right now, the concern that we have is to be able to show all the underlying data that is being signed in MetaMask. Is basically do a tighter integration with front-end representation of 712 signatures. But yeah, we're also looking for any feedback from the community, and more than happy to include additional features if there is a request.
So how would like, let's say I'm a community member who has like some feedback. How do I get in touch? What do I do? I like a PR,
Open an
like,
issue on GitHub. Yeah, issue on
go.
GitHub. I would say, yeah, it's not gatekept. It's a standard way to do things, and yeah, please.
Sweet. All right, thanks, guys.
Thank you.